Let us go into the k nearest neighbors, right? A good algorithmic program to start with both classifiers as well as in the regression scenario also. Right? Let us see the k nearest classifiers first. We'll go with some scenarios instead of directly going to the algorithm. What actually happens with a k nearest neighbors, right? So how it differs from other classifiers, right? Can you name me some classification algorithms you have already learned? Yes. Can you name any classification algorithms you have already seen?
Decision trees.
Great. Decision tree learning. And
SVM.
SVM, okay.
Logistic regression also
Great.
classification algorithm only.
Yes. I was expecting that answer, right? We have logistic regression with a thresholded answer. Now, another answer which I was expecting is decision tree learning. So, while studying decision tree learning, we put one small statement that even if the data set is containing some outliers, decision tree learning will perform better, right? Why? Because it is having something called as entropy, which is actually a purity detector, right? It will detect the impurity in the data
Sir,
and will try to eliminate that.
in Kane, if sir, if Kane, if we have outliers, means our model will get affected, right?
Great, great,
Means
very
it
good,
will show some bad results.
great. So that is what we are going to discuss.
Sir, one
So
doubt, sir.
yes,
Sir,
yes, you can.
decision trees, we are using entropy, right? For
Yes.
entropy, right, in decision trees for model purity, for checking model purity. We can also use Gini purity, right? Because we can get rid of some calculations like logarithm calculations we can use.
Yes, you want that entropy to be used in k nearest also.
No, sir. Decision trees we are using entropy, right?
Yes.
Instead of entropy, can we use Gini?
Yes,
I'm asking.
Gini is nothing but how much data is actually supporting the fact that the data is pure. How much data is supporting the fact that that particular data is impure. That is actually called the Gini, right? Hope you know that. Gini is nothing but we say some data as impure if it's having an entropy value. We say some data as pure if it is having some this particular information gain value. But what is that Gini? Gini says that how much data, how much percentile of the data is actually saying this particular thing is impure, this particular thing is pure. That is actually Gini, right? When you go into the programming evaluations of decision tree learning, we directly use the Gini metric and solve. But when we use pen and paper, we don't have that much amount of supporting data and we cannot calculate that Gini metric for everything. So we just calculate entropy and just find the root alone. If we draw the entire tree, then we can say that how much percentage of data is going to support that particular impurity. Yes, this is impure. Yes, this is pure. How much data is going to support? Yes, 9.6 data is going to support. Like that I can say. So that is actually the Gini metric. So the thing over here is like you can say we have decision tree learning. Many algorithms are here, and I'll as she said some outliers. I also put some outliers over here. Something over distributed and overlapping. Right? Can I say this as overlapping? Why? Because by the color I mean that they are one set of data points, and this gray can be one set of data points, and this black can be another set of data points. Now what I trying to do is now I need to take another new data point and put it somewhere over here. I'll put it somewhere over here. Now, what is my own thing is I need to identify what kind of point it is. Whether I need to classify this particular point as either belonging to this category, that is gray category, or whether this is going to belong to this black category, right? Now, as you said already, logistic regression, decision tree learning, and we also have SPM. We have Bayesian classifiers. Many classification algorithms we actually have, right? Those classification algorithms, what they actually do, if we consider a logistic regression, it will try to draw a straight line over here, somewhere over here, and it will say that above points are going to be and it will also have a sinusoidal wave, and this sinusoidal wave is going to have a threshold above which I say all points are belonging to category 1, and below which I'm going to say all points belong to category 2. So I say that these three black points are also termed as category 1, right? So the main drawback of logistic regression is if the data is overlapping, right? I say that If the data is overlapping, that is more distributed. Here, see, these data points are being overlapped. If the data is overlapping in its distribution, then logistic regression cannot be used. Yes, that is the main fact, right? Because if it is more overlapping, I cannot draw a straight line and say that above are actually true and below are actually false. I cannot say like that. Similar reason I can add for SVM also. Similar reason for SVM also, because SVM also is said it puts a hyperplane and it says that the things above the plane are actually true and below the plane are actually false. A two set. If it is multi-dimensional, I'll use a kernel. Similar reason for SVM also. So what we have actually do is now we will be going for something called as decision tree learning. So what decision tree does? Decision tree will take some element as a root element and says that how I have to make the calculation. Here also what happens if the data is having highly distributed. It is actually termed as these data are actually distributed and not outliers. They are not outliers actually. Just because they are present in this category, they need to be classified efficiently. That is actually the problem here. So it doesn't mean that if it is present in another distribution, it is an outlier or an error term. So there will be some algorithm which uses some instances, and based on that particular instance, it should say that whether it is actually belonging to this category or don't belong to that particular category. So that is what we have to decide. Yes. So let me erase these points. Now our task is this red color X is going to belong to this category or this category, right? That is what we need to do. A very simple thing. A person came and said that you don't do a classification task. Yes, your output is going to be a classifier. What is that is I'm going to classify whether X belonging to gray X or X belong to black X. That is actually a classification task. But don't do that as a classification thing. What you are going to do is I'm going to apply something called as a distance measure. I'm going to take a distance measure. Now,
Euclidean distance.
great, very good. I'm going to discuss that. So we have many distance measures, and the most widely used distance measure over here is Euclidean distance measure, Manhattan, row distance measure, chi-square metric. Many things are actually here. So use a distance metric to calculate the closeness of a particular data to be classified, right? How close that particular data with respect to each category, right? Now, distance metrics normally preferred are Euclidean distance, as he said, the same thing I'm going to say again, Euclidean distance, Manhattan distance, and you can have chi-square, you can have row distance and anything, right? So we are not impressed about these formulas. You know that this is the Euclidean distance is nothing but, I'll change the color here. This is nothing but I say x2 minus x1 the whole square minus
Y2 minus Y1 whole square.
great plus y2 minus y1 the whole square root. So this is actually the Euclidean distance metric which says that whether a point is more closer or not. So what is the task that I'll do in k-means clustering is task number one, select the k value, right? Select the k value. Now understand clearly, many sites or many books says a different point about the k value. Let me say what is the definition of k with respect to Andrew Ng Stanford, right? I'll say the definition. K says k is nothing but k in that k nearest neighbor says that the number of nearest neighbors to the point x comma y under consideration. This is actually the definition according to Stanford for the k. But some sites may say that if k is equal to 1, it means that the point x comma y is actually the nearest point to itself. That is actually the definition that is given by some sites. But don't think those things. If it is k equals 1, it means that give me a neighbor that is as close as to me. I'm not a neighbor to myself. For example, if you yourself can say I'm having a point over here that is red. For red, which is the most closest point here? For red, which is the most closest point here? I can say this black.
That black one.
Yes, this black is actually more closest. So when k equals 1, I can say the first nearest neighbor to me, right? The first nearest to neighbor me. If I select k equals 1, then immediately I can say that this red point belongs to category black, right? So when I say this red point is going to belong to category black, immediately the answer given by logistic regression will be wrong. The answer given by SVM will be wrong. The answer given by decision tree will also be wrong. Why? In logistic regression, if you see, it will draw a straight line and say whether red is going to belong up or down. When it is going to belong up, the maximum number of points in the up is gray, and it is going to classify red as gray. But when you use k nearest neighbor, I'm saying that the most closest point here is black, so it is going to be affected. Now I add upon the fact said by Yugender that if suppose this black is going to be an outlier, then k nearest neighbor will get adversely affected because k nearest neighbor is greatly affected by the outlier point. Right? I'll repeat again. The point is we have logistic regression, we have decision tree learning, we have SVM. But all the things what it will do, they are acting on a straight line or a hyperplane. And based on that above or below feature, they will classify the particular new point. But k nearest neighbor is slightly different. I am not going to classify with respect to a regression line or a hyperplane. Rather, I am going to find how the distance are going to be with respect to the new point, and based on that distance, I am going to calculate. This is actually the thing said by k nearest neighbor. So if it says like this, logistic regression, decision tree learning, and SVM says that this black is going to be an outlier. Why I am saying this as an outlier? All the blacks are over here, but this point alone is somewhat further from this particular black area. So what I say, this black is an outlier. Who says? Logistic, decision, and the SVM says that. But k nearest neighbor says that this is a good point because k nearest neighbor don't care about outliers. There is no mechanism to treat it. Yes. So this is actually the case. Then you can then you can immediately ask that then if k nearest neighbor is not that much efficient with outlier, then why we have to use that? We say that this black point, if it is becoming an outlier, we don't use it, right? But decision tree learning, whether it gives any information about this particular data point and says that this is outlier, no, there is no proof. It simply says this point is more far from this whole set, so it is an outlier. So it may consider like this. It is impure, but there is no evidence to say that this particular point is outlier or not. So before considering whether any point is going to be an outlier or not, we cannot have any proof to say. So that is where the logistic regression, decision tree learning, and SPM is going to fail. And I'll come back to k nearest neighbor. Immediately, what I will do, then again comes a question: if I need to choose a nearest neighbor to the new point, and if it is going to outlier, then how k nearest neighbor is going to answer my question? What I can simply do, don't have k is equal to 1, increase the k value. Yes, so that is actually the thing. Now, we have already seen how the k value is going to differ, right? For k means clustering. Can you suggest how the k value can be found for the k nearest neighbor? Yes, how can we find that? I want to find a
Gap
perfect
analysis.
k value. Very good, very good. Shirdi, gap analysis, okay. Uh, a small question, you can consider me like a doubt also. That gap analysis you are going to do with a distance metric or some other clustering metric, Shirdi?
Error analysis, sir.
Error analysis is a very good thing.
Distance.
Distance metric. So again, you are going to find a distance, then fine. So I accept what Shirdi says. It is going to be gap analysis, but I don't say it with the word as gap analysis because gap analysis goes with clustering techniques. In clustering, also we use distance only. But the fact is correct. You are going to find how if for k is equal to 1, as you can said, how much error will be there. For k equals 2, how much error will be there, I have to find, and finally I should find whether I have to fix 2 with what k value, right? Now let's
Sir,
suppose
or
assume that
else
yes,
we can give some n number of k values like 1 to 10 or 1 to 20.
exactly.
By the within that range, we will conduct the error analysis. How much and we will plot the graph, and by plot we can choose the best k values, sir.
Yes, Yugender, hope I don't know whether you remember the fact what we have said using during K means clustering. You remember that, or I don't know. Exactly the same thing I'm going to say after half an hour. Very exactly, you are correct. But that is what I'm going to say. Not for 10 points. That 10 is going to be a hyperparameter that I'm going to fix based on the whole data set. But answer you said was perfectly right. Right. Do you remember that clustering for also in our programming we did that gap analysis? Do you remember that? Yes, Yugender.
No, sir, I don't remember.
What that immediately you forgot. Okay, now if I say k equals 5,
That is repeating, no, sir.
yes, come again, children.
Nothing, sir.
Yes, yes. If k equals 5, now what happens is my answer may somewhat be different. If k is equal to 5, what will happen? I need to find 5 nearest neighbors to me. So the second nearest neighbor can be this x, third nearest can be this x, fourth can be this, and fifth can be over. I can find this as the most nearest neighbor. So I'm having like this. So in this pi nearest neighbors, how many neighbors are supporting gray? Two nearest neighbors are actually supporting gray, and the three nearest neighbors are supporting black. So if I have k equals 5, at that point, what I have to do is how many neighbors are being supported by one category, how many neighbors are supporting the another category, and I'll say that, and based on that, I'll say that the maximum people are supporting black. So I go with the classification of red as black. So I name this red also to be black. Right? Can you understand how to fix this uh, k value? If k is actually being the it is hyperparameter, we are going to change it. But if phi is there, we need to see what is maximum. Only one thing what we say about this is k value should always be odd point. It should always be odd. Why? Because if it is even, if 2 points are going to support, if for example if it is k is equal to 4 and 2 points are going to be supporting category 1 and 2 points are going to be supporting category 2, then there will be a tie. So always k value will be an odd number, right? This is not the case with other clustering algorithms, but here in k means clustering we don't say that. But in k nearest neighbor, we require the k value always to be an odd number, right? So the some things what we can actually take over, like asking you a question within 30 seconds, or like this question. I'll be asking questions like whether a k nearest neighbor is a classification algorithm or a regression algorithm. This is the first question I'll ask.
Classification.
That's what an
Classification.
error. Wait, that was an error you're going to do. This k nearest neighbor is not only a classification algorithm, it can also be used for regression. So that is the thing.
But maximum cases లో classification వాడతారు కదా.
No, no, no. Maximum, we don't say that it is always going to be used there, because so that only I stated here like classification scenario. Next, immediately I'll say a regression scenario. That's it. So the thing is not only classification. That is what the speciality of k nearest neighbor. One of the basic classification algorithm or regression algorithm, right? But the thing is, it is going to be used both for classification and regression. How it is going to be used for regression, we'll be seeing now. So that is question number one. Question number two: what is the main draw? Or if I ask a question like, if the distribution of two set of categories are highly overlapping, which particular classification algorithm you will prefer, whether it's going to be decision tree learning or an SVM or a k nearest neighbor, or you say something like logistic regression. If it is highly overlapping, which algorithm you will prefer? Like if I have here many black points, I can put here another black point, I can put here another black point, and bottom I can put many gray values. Here I can put some gray values. So if the data point is like this, then which algorithm you will prefer?
Decision trees.
No, no. Decision trees, it is meaning the maximum people. In decision trees, you'll be saying outliers will be there. But in decision trees, we don't encourage more overlapping and all. Just the importance of decision tree is they will be acting on outliers. Now, if you see decision trees, now I ask you a question. In decision trees, this point will be considered as a point or an outlier.
Point only.
Right? Think clearly. All the majority of points are in one side, and this point alone is in black color area. Whether it will be considered as an outlier or a point. And see,
Outliers.
yes, this point is also going to be an outlier, while these blacks are going to be an outlier. Without any proofs, decision tree are going to consider these as some blacks, or these are going to be some outliers. But in k nearest neighbors, you don't see anything as a perfect outlier or perfect error. It is going to consider everything as a random point and it is going to act. But how to get rid of those outliers? Just increase the k value. You increase the k value to a maximum extent, and there is a procedure for finding the k value also. We'll be seeing that practically. And using that particular k value, I can identify the best classification for me, right? So these two questions will be very clear. One thing is k nearest neighbor is not only a classification algorithm, it can also be used for regression. That is point number one. Second, if I was going to use k nearest neighbor, even though my sample is highly overlapping, that is some points over here and some points over there, if I have like this at that point also, I can use k nearest neighbor, right? These 2 points are most important. See, this is the thing, right? Now another small question I want everyone to answer, that I didn't say that we at some point we say, right, k means clustering works only on numerical data because it uses distance metric. Now I ask the same question to you. K nearest neighbor, will it work on categorical data? I mean the data, that string data or something. Whether K nearest neighbors works on categorical data?
We have to change that category
Yes.
also. We have to change, sir.
Yes, I want to change it using dummies. I need to change it
That
into
means
dummies and I have to find, right? So that
one
is
hot
actually the
encoding.
thing, right? Now let us see the regression scenario of this K nearest neighbors. Shall I erase this?
Hmm. Yes, sir.
So let us go and see how the regression scenario is going to happen with respect to the k-means cluster. A similar kind of point we can actually have it. Let's suppose I have a same kind of structure and I have the points over here. Now, in classification scenario, we said two side of categories are going to be there, and I'm going to do a classification that whether it is going to belonging to gray category or black category. In regression, it means that it is going to be continuous data and there is no discrete items going to be present and there are no several categories also. Everything are going to be same. So I'll have several categories over here. All are of actually same points. I'm not going to do any classification. So all are going to be some same points. Yes, I have the data points over here. Now we have to see how the new point is going to be get affected. Right now I take a new point, I take another red point over here. Now I put the red point over here. Now for this red point, there is going to be some x and y value. I'm going to have some x value. I'm going to have some y value, which is not known to me. So what will be the y value for this? This is going to be a doubt for me and I need to calculate this y value. A regression scenario, right? I'm going to say this as a regression scenario. Now, can anyone suggest how k nearest neighbor can be used for this? All are same data points. So say, what I'll do, I'll use the same distance metric, right? So I'll use some same distance metric. And what I'll find, we'll fix some k is equal to say 5, or I'll fix some k is equal to 7 this time. Any odd number values I can take. I can find this is going to be my first k is equal to 1. This is going to be k 2 nearest neighbor, 3 nearest neighbor, 4 nearest neighbor, 5. In this way, you can also have even number because there is no two sets. 6, and I can say this is 7. So this is actually the nearest neighbor to this red point, right? Am I making it clear? This up to this, am I making it clear?
Yes, sir.
Yes. Now what I will do is, I'll normally take another set of groups, and I say that these groups are actually going to be a similar set of groups like this particular X point. Now what I will take, I will combine all those similar groups as X. I will take the mean of all the y values of this particular thing. I'll take the mean of this, and that particular mean I'll substitute it to the new point. The mean will be corresponding to this particular point. So I'll take the mean, and the mean of that particular set will be actually the y value for the new x. This is actually the regression scenario of k nearest neighbors. I just take the distance, and I'll take the closer points for the red x, and what I'll do, I'll group all those closer points, and I'll take the mean of those y values and say that will be the predicted y value for the new x which has come inside. So this is actually the regression scenario for the k nearest neighbors. Right? Am I making that clear? The regression scenario?
Yes, sir.
Yes. Now if I ask k nearest neighbor, if I say knn, whether you say it is going to be a classification algorithm or a regression algorithm.
Both.
Yes, it is both a classification and a regression algorithm. Classifier as well as regressor. So it is going to do both classification task and regression task. Instead of writing this, I can use some paint excel photo.
C or సరిపోతుంది కదా.
Okay, C and R.
Ah,
It is going to do both classification as well as regression. Both the things is going to be done. Point number 2. What will be the k value when it is going to be classifier? It can be an odd value or an even value, or any value can be there.
Any values.
Come again. It is going to be a classifier.
ఆడా.
Yes. Why? Because if I select k value equal to 6, and the 3 people are saying that it is going to be belonging to gray, and 3 people are going to say it is going to belong to black, then there will be a tie. Am I right or wrong? Who will break the tie?
You.
So if I take some odd value, surely anyone will say more, and I'll take the maximum one and say that particular thing will be better, right? So k value should always be black. Sorry, odd. Next, coming to the main thing, this k nearest neighbor will also work only on numerical data items because it uses a distance metric. When it uses distance metric, I need the data points to be numeric, right? So data points in k nearest neighbor should be a numerical value. Data points in KNN need to be numeric. So that is actually the thing. And if it is numerical, there is again the point, the struggle will come. If the data points are numerical, they need to be scaled well. They need to be scaled well. Scaling is nothing but if, for example, I have a data point X, I'll take this instead. I'll have a data point X, X1, and I have another data point X2, or I'll take Y. And for X, if I say the value is 2, 3, 5, like this, if I say the value. And for Y, if I say the value as coming to be as 10-digit value or a 5-digit value or something, it is nothing that a small linear value and a very big value is going to be considered. I say the values are going to be like this. Then what will be the endpoint? The endpoint will be like something, a very big value which I was not able to calculate. If I plot this 2, 3 versus this, surely I cannot find a line or any other plane. Surely it will be difficult. So it should be scaled well. Data point should be scaled well. So the point should be numerical as well as scaled well. And when I should use this k nearest neighbor is only when the data points are highly overlapping. Only when the data points are highly overlapping, we say that KNN is suitable for classification. Otherwise, we have many classifiers starting from Bayesian classifier, we have decision tree learning, we have logistic regression, we have SVM. Many classification algorithms are available from the base itself to do that classification task. But those classification algorithms have a commonality. Both logistic regression as well as SVM will have a commonality, meaning that they will use either a regression line in terms of logistic regression or a hyperplane in terms of SVM to do those classification tasks. But in K nearest neighbor, nothing is used. I don't consider anything as an outlier. I don't eliminate any points. I will do what is actually correct. I take all the data points. I will find the distance between each of those data points based on the K value, and I'll find the point which is maximus supporting a particular category. I'll go to that category. So that is what the principle of K nearest neighbors, right? So this is the thing. Another important criterion about the K nearest neighbors is this K nearest neighbors can also be used for image processing tasks. You hope you have seen algorithms like PCA, eigenvalues like again that you did last seminar, right? So there are algorithms similar to that which will be actually doing such a task. So what will be they are doing? They'll convert my image processing algorithm images into some matrices, and they will reduce those matrices into a lower dimension where my values, which is going to depict the features of the images, is going to reflect only the important features. Only the key features are going to be extracted. At that point, when I get another image which is having a particular key feature, and if I need to compare and say, I need to classify whether they belong to this particular category of images or another particular category of images, then I can easily say that K nearest neighbor with K is equal to 1 will efficiently support you. Or if you want to choose that K to a particular good value, you run an algorithm like Yugender said, you run it for a for loop starting from 1 to at least 10 percentage of the entire data set. You run it and find a better K value, and you will get that particular result. So this is actually the thing. Say for example, we have something called as weed classification. Do anyone know what is weed that will grow in agricultural lands? So this is actually an agricultural crop, right? What is called as weed? How many of you know agriculture, or your fathers are usually doing this agricultural thing?
Weed ante that spoiled plants.
Yes, spoiled plants not. They are going to spoil good plants. These are good plants, and they will grow in between and get the nutrients of these points. Right? There is an efficient project that actually does how these weeds are going to be recognized. Right? These are also images. I need to identify these weed images automatically and cut it off in such a way that they are not going to affect the nutrients that is going to be received by this particular plant. So what I can do, I can just do an image processing algorithm. I can use either PCA or eigen reduction and bring it to a lower dimension and apply such classification algorithms. These classification algorithms can efficiently detect these binary classifications, whether a given image is going to be a weed image or a normal plant. These kind of simple calculations can be very good done by using the k nearest neighbors. Why I particularly say this k nearest neighbor is much suitable is this nearest neighbor will not consider anything as outliers or will not omit any data points. But you can ask me a question: if the data set by default contains many outliers, then I itself will say don't use k nearest neighbors, because if more outliers is there, first we have to do outlier reduction. We need to act on those outliers, then we need to come back, because we have many outlier reduction techniques, and based on those outlier reduction techniques only we will be doing an action. So this is the case, right? Once you did those outlier reduction activities, you acted upon the data and made it as pure as possible. You come back to these nearest neighbor algorithm and you use it. That is actually the case, right?
Sir, through box plot we can detect outliers, sir.
Come again?
Through box plot we can detect outliers, sir.
Yes, of course. If you put box plot, what will actually happen is I can actually find the percentile. So I'll draw the box plot here. If I draw a box plot, what will actually happen is I'll actually have a point, and my box may be something related to this. And this box
Three
plot
points
says,
average.
for example, this point says me the mean,
Average. Mean
and this
or
will say 75 percentage of data, and this will say me 25
25%
percentage of the data, 25
or
percentile of the data.
outliers.
You can say that you cannot detect outliers directly, but you can understand whether the data set is having outlier or not. If 75 percentage of data and 25 percentile of data is actually in the making the mean to be in middle, then it is fine. If the data set grows like this, I'm having like this, and it is like this, and my 75 percentile is over here, and 25 percentile is over here. So this actually means that if you say that this is going to be an age feature, and if I say that number of people over the 75 above ages, 75 percentiles of ages is going to be only this much, and these many people are going to have an average of 25 percentage, 25 percentage, then, and I can say that this is somewhat actually biased. More number of data are over here and less number of data is over here. We can actually recognize that whether the data set is having outliers or not, but we cannot detect whether outliers, which point is actually outlier in backplot.
By using Z score, we can identify, right?
You mean Z square? Z square is just Z score. You mean, right?
uh,
Z score is actually a scaling technique. Min max and Z score is actually a scaling method. We min max score or the Z score. By using that, we can actually identify what are the scaling methods. How we have to scale it. Those things. Normalization. They are actually normalization techniques. How can you detect outlier is, it is very simple. One of the basic thing what we can detect outliers is your mean. That is what represented by the box plot. If your mean is actually seeing many points deviated from it, that itself it says an outlier. But many real-time scenarios, only using mean alone is not enough. We have many outlier reduction scenarios. If possible, we'll have a separate class on outlier itself and see how outliers can be detected. Okay. Yes.
sir,
It
that
can be removed, no,
outliers
sir?
class you record and keep,
Outliers
sir.
need to be detected. Outliers need to be detected.
And also it can be removed, sir.
Yes, should be. It should be
Uh,
removed, but we cannot say that all the outliers can be detected clearly. And if you only have several data present, you can remove the outliers, or we need to replace outliers with some correct values.
or
Sir, in
we need to check
KNN we
the
can use dummies.
dependency.
One by one, one by one, one by one.
In KNN we can use dummies, no, sir?
Yes, of course we have to use dummies. If the data is categorical and I need to convert it into numerical forms, we have to use dummies.
Sir, actually, we can detect outliers with the help of
With the help of
Z score.
jet score.
Z score. So Z score is
Yes, sir.
actually say Z score will actually say your normalization factor, right? Anyway, we
No,
have
sir,
Sir,
no, sir. There is
Sir,
a
but
there is a technique, sir. If we have Gaussian distribution, right? A Gaussian distribution, we are going to set some threshold value. If the threshold value is greater than this Z score, means we can detect it as a outlier
yes. Then if you
by
want to
using
fix any threshold, it may be right.
by using Gaussian distributions, we
sir.
can detect.
Yes.
We can detect.
Yes. Now we'll plan. We'll plan for a separate class for outliers also. Then.